Hi folks, in this video, I'm going to show you how to perform a paired sample t-test using JASP. First open up JASP. Once JASP's open, go to the top left corner where it says Show Main Menu. Go to Open, go to Data Library, and choose t-tests. We're going to want to choose the Moon and Aggression dataset since it says that the file demonstrates use of a paired sample t-test. Once you open it, become oriented with what the data is about. In this case, because we have one group of patients who live with dementia and the dependent variable of interest is the number of disruptive behaviors that is being measured under two conditions, when there is a full moon and when there is not a full moon, a paired sample t-test is appropriate. To perform the paired sample t-test, we're going to go to t-tests, paired sample t-test. We're going to grab both of our dependent variables of interest. We're going to move them over to the variable pairs box, and we're going to have our t-test. Before we go ahead and do that, some other things that we want to think about is selecting our descriptive statistics and our normality checks, since we need to verify that there is a normal distribution under both the moon condition and the control condition. You can see that there is a mean and a standard deviation for both the number of disruptive behaviors, which is our dependent variable of interest, when there is a full moon and when there is not a full moon. So we have those means and standard deviations available. To check for the basic assumption of a normal distribution, remember, we're interested in whether the difference score, the number of disruptive behaviors for the same person when there is and is not a full moon, if that distribution of D is statistically different from a perfectly normal distribution. So we can check it by looking at a histogram, we can check it by performing skewness and kurtosis statistics, or we can check it with the Shapiro-Wilks test statistically. And remember, if we do not want our distribution to be statistically different from the distribution of a perfectly normalized distribution, the p-value should be larger than 0.05. And in this case, we see that it is. Once we verify the basic assumptions, we can come back up and explore the paired sample t-test. The p-value is statistically significant. And we know it's statistically significant because the p-value is smaller than 0.05, which represents our 95% cut point. Once I know that there's a statistically significant difference, how do I know which of the two conditions had more disruptive behaviors in the sample? Well, then I go back down to the descriptives. And when I look at the descriptives, I can see that there is on average 3.022 number of disruptive behaviors plus or minus 1.499 number of disruptive behaviors when there is a full moon, compared to 0.589 disruptive behaviors. And so I need to be aware that when there is a full moon, I can expect there to be more disruptive behaviors than on non-full moon days. So I hope this video was helpful. We'll see you all in the next one.